Hey, Science 10, welcome to chemistry. After this chemistry welcome video, there's a chemistry welcome assignment. Make sure you've got your periodic table. Let's get underway. Let's start to talk about what is chemistry. Chemistry is the study of matter and its physical and chemical properties. Let's just take a quick look at that. So all matter has physical. This is bendable. These are shiny. Interesting. So all matter has physical and chemical. Fire. All matter has physical and chemical properties. Here's a chemical property. Ooh, fire. Here's some physical properties. Look at this. Look at these metals. This is copper. It's bendable. Look at this zinc. It's bendable too.
So in this video, we're going to learn those three key things. First of all, what is matter? Second, what causes those physical properties that you just saw, the color and the ability for those metals to be so bendable and malleable? And third, what causes chemical properties? What caused that fire? Why are some substances chemically reactive? Okay, your first step, you got to get out your periodic table. So make sure you've got that in front of you. Let's take a quick look at it. All matter is made up of atoms. The periodic table has all of the atoms. These are very, very rare in their pure form, actually. But you can find some of these elements in their pure form, you know, stuff like gold. You can see at number 40, no, sorry, not number 79. It's silver that's number 47 there. They can be found, but they're still extremely rare. So all the matter around you, all of the solids, all of the liquids, you know, water, all of the gases in the air, they are made up of atoms, but most of them are not in their pure form.
So this copper, for example, you can't find this in its pure form out in nature. This has to be manufactured. This actually takes a lot of energy to do it. We will find copper generally out in nature as copper oxide. And so most of what's around you isn't pure elements and pure atoms like this. Most of what's around you are compounds, which are two or more different elements bonded together. Let's look at that.
So that pure copper, it can't really be found out in nature. You can't virtually, again, we can't find hardly any of these elements out in their pure form. Copper is going to be found like this, as copper oxide. And ultimately, what we have here is a compound. It's two or more different atoms bonded together. This is actually an ionic compound is what this is called. And ultimately, the copper atom, two of them, have bonded with one oxygen atom to make a brand new substance. These rocks, for example, they're going to be a mixture of, well, mostly compounds. There are going to be some elements in there, but they're extremely rare. So, yeah, ultimately, most of what we see around us is indeed mixtures of compounds and elements all kind of mixed together.
Another compound that you know about is water. And of course, water, we all know, or should know, is H2O. So that's two hydrogen atoms bonded to one oxygen atom, H2O. This is a model of what the hydrogen molecule, okay, so a molecule is two or more atoms bonded together. This is a compound, which is also a molecule, which is two or more different atoms bonded together. Look at this water, H2, there's our two hydrogens, and oxygen down here.
So you saw the water there. And well, let's take a look at it on the periodic table. Of course, water is H2O, as I was just mentioning. So it's two hydrogen atoms bonded to a single oxygen atom. There's the model of water. And again, most of virtually all of the water we have is a solution. It's going to be dissolving some of these ions I was just mentioning, you know, sodium, chlorine, definitely there's going to be some calcium, could be some iron ions. And a reminder that an ion it is an atom, but they've either lost or gained an electron.
Everything around us really, it's very rare to find those elements in pure form. And even this water isn't pure H2O. Water is going to have many things dissolved inside of it. In fact, it's going to be called a solution, which is kind of like a mixture, but it's properly called a solution. So this water came out of the tap. It'll most certainly have different ions dissolved in it, probably some calcium, probably some chlorine, probably some sodium, some magnesium, some of the other ions. And a reminder, an ion is an atom that's either lost or gained an electron. So indeed, there's some other things in here, and it's why it's called a solution. So yeah, most of the water around you is going to be a solution.
So most of what we have around us are mixtures, are mixtures of compounds. So compounds like copper oxide here and compounds like water mixed together with elements. Water itself, we call it a solution actually, right? So yeah, so most are mixtures or solutions. But there is one place where you can find pure elements. In fact, some of these are found in their pure form. Let's take a look at that.
One of the places we find pure elements is all around us. It's the air. Now, of course, it's still a mixture, the air. It's going to be a mixture of mostly nitrogen gas, or N2, and oxygen gas, or O2. About 78% nitrogen and about 21% oxygen gas. So almost all of what you're breathing in right now is pure nitrogen gas and oxygen gas. Again, as a mixture though, but indeed it's a place where we can find pure elements. Now there's going to be a tiny, tiny bit of the gas around us in the air here that's carbon dioxide. But actually what you're breathing out right now, because of cellular respiration, you're breathing out a fair bit of carbon dioxide right here. So yeah, so there is a place where we can find pure elements, but again, mixed up. Okay, let's continue.
Okay, so the air that we're breathing is a mixture mostly of nitrogen gas, or N2, and oxygen gas, or O2, and those are indeed elements in their pure form. They're just mixed together. And there are some compounds in the air that we're breathing, you know, carbon dioxide here. And of course, you're breathing out a lot of carbon dioxide right now. But yeah, matter, yeah, it's all made up of these atoms. How small are atoms? Let's talk about that next. Go to your periodic table, find aluminum. You know, it's good old number 13. You can see that right in the top left. That's how many protons aluminum has. And yeah, let's take a look at a sample of aluminum and talk about how small atoms are.
This is pure aluminum, which again, you're not going to find out in nature. It's actually going to be found as aluminum oxide. So we've got a sample of pure aluminum here. And to tell you how small atoms are, there's about 60 billion trillion aluminum atoms in this sample. Take a look at how much that weighs. I'm going to move the camera down so you can see about 2.7 grams. And that, again, that is 60 billion trillion aluminum atoms. Incredibly, incredibly small. That is a 6 followed by 22 zeros. That's a number none of us really understand. It's so huge. But ultimately, what you can understand is atoms are super, super, super small.
So physical properties, you know, like we've seen how those plates of metal are kind of shiny and bendable. That's an example of physical properties. What does the periodic table tell you about physical properties of the different atoms? Well, first you can see that the table is telling us which ones are solid, which ones are gases, kind of a light gray shading, and a darker gray shading for which ones are liquid. Let's look at water as a good example. Of course, water is a compound, but it's still a good example of the physical property of state, of either solid, liquid, or gas. Let's take a look at that.
So an example on states of matter. Water is your best example. Again, water is a compound, but just like all of the atoms on the periodic table, it can exist either as a solid, so we call that ice, a liquid, and you can see, of course, this water is melting into its liquid form, or a gas. Now, you can't see that, but you do know that water does evaporate. If we left this long enough, this would evaporate and we would get water vapor in the air. We see that especially in Canada, and in the winter we see steam as we're breathing out. As we're breathing out, we see steam, right? And also, of course, clouds, right, as an example of water vapor. But indeed, matter comes in basically three states: solid, liquid, or gas. And again, you can't see the gas here, but you need to know there is indeed water vapor in the air you're breathing right now.
All right, so we just saw an example of water showing us these three states of matter, which is a physical property. Of course, water, really interestingly, can exist fairly easily as either a liquid or solid or gas. In terms of these elements on the periodic table, this does indeed show you their state at approximately 25 degrees Celsius, whether they're a solid, whether they're a liquid, whether they're a gas. What are some other physical properties that the periodic table is telling you? Well, let's focus in on aluminum first. All right, so find aluminum on your periodic table. Now, one key thing it's telling you is that aluminum is a metal. And we're going to look at a few metals again in a moment here, just so you can see the properties of all metals. But let's just talk a little bit about aluminum. If you focus in on aluminum, what you're going to see is number 13. This is actually telling you the structure of the very atom itself for aluminum. And that structure actually dictates the mass of aluminum. For example, the mass of aluminum is made up of, right here in the center in the nucleus, it's 13 protons plus its 14 neutrons. Now 13 plus 14 is 27. Oh, that's what this number is. This is the mass. Now, to get the mass for the atom, when you're making models of the atom, and you're going to be making models like these, just drawing them out. When you draw out this atom model, you're going to need to round this 26 to its nearest whole, so it goes to 27. So you can see 13 plus 14. But just think of that. Think of the mass of aluminum. It's coming from the very nucleus, the center of that atom. Now, I told you that aluminum is a metal. Here's a couple other metals, copper and zinc. Let's take a look at those and talk about the properties of all metals.
So take a look at these two metal elements and their properties. They are in their pure form here, and so we can see some zinc. I've got a copper wire right there, and also copper right there. So properties, physical properties, you can see. We can see a different color. We could measure the mass of these. Another interesting physical property of all metals, it can be stretched into wires. And metals are very, very, very malleable, very, very, very bendable. We can bend metals. So those physical properties are dictated by the protons and neutrons, especially for the mass. But your protons will give properties like your color and your state. And so these are two examples of some metals, zinc and copper, on your periodic table.
So we've seen the properties of metals. Let's look at a few other elements on the periodic table. These ones, in fact, happen to be non-metals. They're on the right of the staircase. And again, their properties are actually going to come right from the very structure of the atom. Carbon, if you take a look at it, number 6, it's got 6 protons. Nitrogen beside it has 7 protons. Just that one proton is very different. Look at what carbon is. It's a solid. In fact, it can form diamonds under the right conditions. This is pure carbon. A diamond is pure carbon. Nitrogen gas, you're breathing that in right now. And so just one proton gives a very big difference. So, again, to be clear, that's the proton number there on the top left. To get our mass, we add our protons plus our neutrons. That's going to be that 12 right there. So there's the mass. And protons and neutrons, so they're responsible for mass. That's one of the physical properties. But also state and color, right? Almost the very nature. You can kind of, again, tell that difference in proton number between carbon and nitrogen gives quite a difference. Next, we're going to talk about chemical properties. Where do chemical properties come from? Well, we haven't mentioned electrons yet. So it is actually from the electrons, what we call the valence, the outside electrons. And let's take a look at that right now. So chemical properties. Okay, so yeah, just a quick summary. All matter is made up of atoms, all right, and atoms have unique physical properties, you know, like mass, color, and state. Atoms also like to bond with other atoms to make compounds. We've seen that. So here we've got sodium, right? Now sodium, if it's a metal, you can tell. If I put sodium in my hand would burn off. It's incredibly reactive, incredibly dangerous, super dangerous. Here's a non-metal, chlorine or chlorine gas, Cl2 is actually how we write it. And it's incredibly dangerous. So these two have a chemical property of incredible reactivity. They're incredibly violently reactive. And this is really chemistry at this point, right? When we see fires happening, this is literally what happens when sodium and chlorine come together. There's a fire, but they make stable table salt, which is tasty and wonderful and safe, and that's amazing. And how does that happen? It happens right here. You can see the model of the sodium atom right here, and here's the model of the chlorine atom. And what you're seeing is that the sodium atom gives one of its valence electrons, and it stabilizes it. It basically allows it to not be so crazy reactive. And the same with chlorine, by giving it that one electron, it stabilizes it, forms a bond, a fairly strong bond called an ionic bond, and makes a stable substance, makes a solid, stable substance. And yeah, so this is what happens when actually any of these metals on the left of the staircase react with any of these non-metals on the right of the staircase. The metals, in fact, this little charge here on the periodic table is telling you how many electrons they give away. This negative charge for the non-metals is telling you how many electrons they take. And that's literally what's happening in this picture here. This is showing you, of course it's a model, but this model is showing you what happens in a chemical reaction when a metal and a non-metal meet. Sure, there can be tons of energy released, but at the end, we actually get a stable, solid substance. And yeah, that's pretty amazing. So what have we learned so far? All right. First of all, we've got, let me just back that up, actually, I don't want to quite go to that page. First of all, we've talked about the structure of the atom. And the structure, the very structure of the atom dictates physical properties. So, you know, what we see here, we see this shiny metal, dictates the mass, right? The very structure dictates the mass as well. So protons and neutrons give us our mass. Protons really give us our color and also the state that the element it is. And we've also learned about chemical properties. Again, coming from the very structure of the atom, coming from the electrons, the valence or the outside electrons. And we can see a chemical reaction happening right here. We also know that matter is made up of atoms, right? We've got a bunch of them here, not the whole periodic table. And of course, atoms love to bond with other atoms and form compounds. Okay, so one more thing for chemistry, for your intro to chemistry, the periodic table. Again, make sure you've got it printed, but you want to be able to convert and use this periodic table to take words. So these kinds of words, you might read them, you might hear me say them. So if I say nitrogen, if I say oxygen, if I say butane burns, we want to convert these words into formulas. And then in the case of butane burns, into an equation. Okay, so let's look at that. So we take the words nitrogen, and the formula would be N2. You just need to know that. That's how nitrogen exists. We take the word oxygen. It exists as O2. That's how it exists. We take words like butane burns, and this is an equation. Now we're just starting, so you don't need to know this all just today, but this is what you're going to be able to do at the end of chemistry, is take words like butane burns and realize, okay, when something's burning, that's oxygen. And of course, butane, you're just going to want to write that down on your periodic table and have it so you know that that's the formula for butane. There's the formula for oxygen. All right, so it's time for you to go and do your chemistry welcome assignment. Remember, chemistry is the study of matter and its physical and chemical properties. Make sure you know what matter is, make sure you know where physical properties come from, and make sure you know where chemical properties come from. Okay, take care, Science 10.